In this video, we're going to talk about t-distribution. First, let's recall the standard and normal distribution. The graph is also bell-shaped, and the horizontal line denotes the random variable, the standardized variable z. And in this section, we don't use the letter z, we use the letter t. We call it t-distribution. And the difference between this section and this chapter and the previous chapter is the sample size. So the sample size usually is smaller than 30, and the sample size can affect the probability. And so we have something called degree of freedom, which is the sample size minus 1. In these pictures, the degree of freedom is given. It's 14. That means the sample size is 15, and 18 the sample size is 20, and so on. So I'm going to work on A and D, and you can follow the examples to do the homework 9.2. Okay, so the meaning is similar to what we have learned before. T is a variable, and again it's standardized variable, and for small sample size, and the area under the curve is the probability as before. This is the same as before. So it's given that the area under the curve of this side, the right side, is 0.05. So that means the probability for this region is 5%. And or you can say, well, if this is 0.05 or 5%, the left side is 95%. So you can call this 95 percentile. So this point right here is the 95% percentile, because when we talk about percentile, we always talk about the area to the left side, not the right side. But so the homework, the 9.2, it says name the t percentile. The t percentile is this point right here, and it's not asking you for what percentile it is, but you should also know that if the right side area is 5%, that means the left side area is 95%, or you can call this point 95 percentile. Okay, so the question, what is the problem is looking for what this point is. So we can use the table given on Blackboard. So the table on the back of the book is not complete, so we here is the table we're going to use. So you can go to week 12 and click on the link, and this is the table we have. So we know the and the t value, the area on the curve is 0.05. So this table is given different from the table we had before for z values. For z values, usually they have a column for z and column and row for z. The number inside the table means the probability, but this one is not the case. Actually, the row, the column means the degree of freedom. So the degree of freedom for our case is 14. So I first found 14. It's right here, and then so this row right here, and then I will check the probability, or you can say the area under the curve. The area under the curve is 0.05. So you will go back to the table and you look at it says one tail right here. You don't have to worry about the two tails numbers. We can always use one tail to find out the answer. And so I will find alpha. That's the alpha 0.05. It's 0.05. It's right here. So it should be under here. It's this column. The value is 1.6761. Okay, so the table given is always for the right side area, and notice before for standard normal distribution, and the probability given in the table is always to the left. So this is a little bit different. Okay, so we found the answer. It's right, this one here, 1.761. So corresponding to degree of freedom 14, and the area under the curve equal to 0.005, or you can say alpha equals 0.05. Okay, so that's how we found that 1.761 for, that's this point right here. Okay, I can do another one in part D. What if the area given is 0.05, and we know the graph is symmetric, so you can look at A and D, and this part right here, I can draw if I can draw a line right here, and I can find out what this point is, and then this point will be the opposite, because the middle is 0. So if this is 3, then this will be -3. If this is 4, if this value here is 4, then this will be -4. So although it's given to the left side area, we can always still use the same number, 0.05, and for this right here. And let me make it bigger. So what if I can draw a line right here, symmetric, about 0, and first I found degree of freedom is 21, and the area under the curve is the same as left side at 0.05. So the reason I'm doing this, I have to, because when I use the table, I need to know the right side area instead of left side area. It's different from normal standard normal distribution. So the right side area is 0.05, and I go to the table. Degree of freedom is 21, so right here, and the alpha value is the area under the curve is 0.05, still the same here, 0.05 right here. So I go down and find out the answer is 1.721. Okay, so 1.721 right here, and 1.721 is for this point right here, not this point, but we know it because of this symmetry. If this is 1.721, then this is negative 1.721. So that's how we find out this value. Of course, it's below 0, so it's negative. So that, so similarly, you should be able to do the homework. Actually, the homework, A and B, they're both on the right side, so you don't really have this case. But in the following questions, we do need to know this property. If it's given left side of area, you can find out the right side point right here, and then make it negative. You'll get the left side percentile. So the percentile, always the meaning percentile is what we learned before. It means the probability to the left side. For example, this one, the area under the curve is 5%. So we call this 5% percentile, which is this point right here, negative 1.721. So that's how you do 9.2, exercise 9.2.